So hello everyone, I'm Shreyas Kar, the founder and CEO of Community AI. And I would like to welcome all of you to our 2020 AI Summer Camp on Machine Learning. We have many students from several cities, states, and countries encompassing many different time zones. So it may be early for some of you guys, and I really appreciate all of your guys' effort to joining today. And as a heads up, we'll actually be recording this lecture. So before we start this lecture, I would like to introduce our organization. So Community AI is actually a student-driven nonprofit organization that aims to empower middle and high school students to create AI-driven projects to help the community. As you all know, AI has boomed in popularity in the last few years and has been used in various applications, including business, agriculture, education, and everything in between, sometimes revolutionizing these industries and having a massive impact on the community. And in fact, if you look around, many of the things are used on an everyday basis, from entertainment products like Netflix to educational products like Khan Academy. They use AI to operate on an everyday basis. And despite AI having this huge impact on the community, not many students actually create AI-based projects. And this to us was very surprising. Because after all, many students were very bright. And more importantly, these students really wanted to make a difference in the community. And this really puzzled us greatly. We would really appreciate it if you muted it. Okay. Yeah, so before we continue, we really appreciate it if you would mute yourself because, all right, thank you. Okay. All right, thank you. So coming back to what I was saying, because even though AI had a huge positive impact on the community, not many students actually created these AI-based projects. And this to us was actually very surprising because after all, many students were extremely bright. And more importantly, they really wanted to help the community. And this experience puzzled us greatly. However, after our experiences, we came to the conclusion that two factors prohibited students from creating these projects. So one was that students simply did not have the knowledge necessary to create these AI-based projects. And this was actually one of our biggest reasons that we created this camp. And number two was that even in students who have learned AI, maybe through online sources, even these students did not have proper guidance to create large-scale projects. And as you go along machine learning, you'll see that there's a huge difference between having a theoretical knowledge in machine learning and actually being able to implement AI in practice. And we discovered that there did not exist an organization currently to help students with these problems. To that end, we created Community AI to empower middle and high school students to create AI-driven projects to help the community. And before we actually start the lecture, I would like to introduce our team. So first, let me introduce myself. So I'm Shreyas Kar, a junior at DuPont Manual High School in Louisville, Kentucky. I've created several award-winning AI-driven projects that have helped the community and the environment. And I have a machine learning certification from Stanford, IBM, and the University of Michigan. Now I would like to introduce our co-founder, Shraman. Shraman, would you please introduce yourself?
Hi, my name is Shraman Kar, and I'm a freshman at DuPont Manual High School. And I also have created several award-winning AI-driven projects and have certifications from Stanford, IBM, and University of Michigan. I welcome you all to this summer camp, and let's all learn AI-driven project and to create AI-driven projects together.
Thank you, Shraman. Now I would like to introduce our Director of Marketing, Rick. Rick, would you please introduce yourself?
My name is Rick Biswas, and I go to Parkway West High School in Missouri, and I also have created many projects and also have qualified for VEX Worlds this year, so I'm really excited to see where this camp goes, and have fun.
Thank you, Rick. And now I would like to introduce our Chief Advisor and Mentor, Dr. Jeffrey Willard. He'll actually be teaching this class. So Dr. Willard, would you please introduce yourself?
Yes, thank you, Shreyas. So as he mentioned, I'm Dr. Willard. I have a PhD in applied mathematics from North Carolina State University. I've held a variety of jobs, working for Los Alamos National Lab and then working later for the DoD. And now I work for a big company in the US called Schneider Electric. It's actually headquartered in France. And our group is responsible for helping people understand their energy needs, their energy usage, and helping build a more sustainable future. So I have a lot of experience in data science and machine learning, and I'm excited to go on this journey with everyone.
Thanks, Dr. Willard. And all of us will be teaching teacher assistants during this course. And if you haven't done so already, join the Google Classroom link. And we'll post the Google Classroom code in the chat here. And we encourage all of you guys to use Google Classroom to finish assignments, engage in group discussions, and send us questions so we can answer them. And one more exciting announcement before we move on to the lecture. And for those of you who attend DuPont Manual High School in Louisville, Kentucky, we're planning to start an AI club this fall, where we'll deliver engaging presentations and work on fun projects. And if you attend Manual and are interested in joining this club, please sign up under the Get Involved section on our website. Dr. Willard, who's our chief advisor and mentor, agreed to visit this club and help our members. And Mr. Lober, who's our AP Statistics teacher here at Manual, is with us today. And he's actually the teacher sponsor of our club. So welcome, Mr. Lober, to the camp, and thank you so much for your time today. Will you please talk about the club to Manual students? Looks like Mr. Lober. Okay. Well, I did see Mr. Lober today, so if he joins back, he can talk a little bit about the club. But now for students who are actually joining from several other high schools and universities, if you'd like to start a club in your school, we can help you actually. So please fill out the partner program form and sign up the Google form. And the Google form for the sign up is in the Get Involved section on our website. So without further ado, Dr. Willard, would you start the lecture, please? Dr. Willard?
Yep. Shreyas, do you want to give up control of the screen? It won't let me share until...
Sure, yeah, I'll do that.
Okay.
Okay. Yep. Can you do it now?
Yep.
All right, nice.
All right, can everyone see my screen now? Shreyas, can you see it?
I can see it, yes.
All right, excellent. All right, so again, thanks everyone for joining, and thank you Shreyas and Shraman for all your hard work getting this set up and putting this organization together. We've already actually accomplished the first two things on today's lecture outline. We've kind of given you the introduction to the community AI and the team, and we've introduced the camp. So with that, let's just jump into our introduction to ML.
And I'm sorry that I missed your introduction, Shreyas, because technology is not always functioning properly. Mine went out just as you were started to introduce me, so I apologize, but I've come back online. I don't want to interrupt Dr. Willett, except for to ask two questions that maybe you guys already know the answer to. I'm sure I will learn a lot more than the students here because you guys are much more experts than I am. I would ask if Shreyas or Dr. Willett or any of the members joining are familiar with Thomas Siebel, the founder of C3 AI, or Daniel Bell, who he took inspiration from, wrote a book back in 1973. I'll leave those questions open and I'll hand it back to you, Dr. Willett. Thank you very much.
Interesting you asked that question. At my last job, I actually worked with some folks at C3 AI in partnership with the United States Air Force. So curious to hear what you have to say about them. So as we give an introduction to this camp, we've got to discuss a couple of quick, more administrative items. So first of all, who is this course for? Well, I think we've found the right audience, since most of the individuals who signed up are middle and high school students, and we're really looking for people who have a curiosity and interest in machine learning and AI. We expect that students have some familiarity with algebra. In most cases, machine learning and AI are taught to individuals who have a background in calculus. We're trying to avoid this because we want to make this as accessible to as broad of an audience as possible. So we don't require you to have any prior programming experience or any knowledge of calculus. So the course goals are to learn about some basic ML concepts and common types of ML problems. And to do this, we'll provide some exposure to some of the most common ML algorithms. And in order to do that, we're going to have to introduce some programming principles, and we will use Python and Octave, two programming languages, to do this. Both of these languages are very common in the machine learning and AI worlds. And then we'd also like to inspire students to begin building projects that benefit their local community or the environment. And as Shreyas mentioned, if you have questions, please feel free to type them into the chat, and one of the TAs will try to answer it as we go along. But if not, we can save it for the end and have a little Q&A session. So many of you have probably seen this, but just real quickly, I'll share the lecture schedule. Today's first lecture is Intro to ML. And then for the next few weeks, we'll be discussing a variety of topics in machine learning, ending with some applications that should be interesting for everyone to hear about. In the future, if you've got more things you'd like to learn about, please drop us a note, and we'd love to talk to you further. Okay, in terms of the class Decorum, a lot of this we've already discussed. Shreyas did a great introduction. As you know, we'll be using Google Classroom in order to facilitate this class. We will be posting an assignment with every class that will be due 7 days after it's assigned. These shouldn't be too technically challenging. The goal is to just make sure you're following the major concepts and are engaging with the class. So they can be taken as many times as necessary, and a passing score is 80%. Community AI plans to share a course certificate with all participants who score at least 80% or above in all of the assignments and attend at least 7 out of the 9 lectures. And our class recordings will be available after the camp, but if you need it before, let us know and we'll try to make those available. So, now that we've gotten all that out of the way, let's talk about machine learning. So in general, machine learning is the study of computer algorithms that learn automatically via experience. So that might be a little tough to decipher, but it's a little bit better than Tom Mitchell's formal definition, which is can be a little bit more confusing, but we'll break it down. He says a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at task T as measured by P improves with experience E. Wow, that probably doesn't make much sense to anybody, but really what it means is a computer program is, we'll consider it machine learning if as we feed it more data and more experience, it gets better at doing something. And that something is generally some machine learning task. We'll discuss various types of those in a few minutes. But we also have to have some way to measure how well the algorithm's doing. And really, what does a machine learning practitioner do? They design these algorithms or employ these algorithms to solve problems within a defined framework. So some of you may already be familiar with this, but there are generally three types of machine learning approaches that are recognized in machine learning textbooks or many of the courses you'll find online. The first is called supervised learning, the second is unsupervised learning, and the third is reinforcement learning. If you were to have picked up a book maybe 5 years ago, it may not have discussed reinforcement learning, but this is actually a really cool topic that is gaining popularity every day, and the field is changing as we currently speak. So first is supervised learning, and this is probably what most people think about when they think about machine learning in general. So the computer is provided with a set of examples and their associated outputs, and the goal is to learn a function or rule which maps inputs to outputs. One thing that you may be familiar with already, but not really associated with machine learning, is linear regression. Linear regression is actually going to be the topic of our second lecture, which takes place on Thursday. But the goal in regression problems is to predict a numerical output based on a set of inputs. So the example listed here, maybe you're familiar with the website Zillow, or Redfin or Realtor.com, but they have a lot of information about homes that are for sale and the price at which those homes are sold. And so they can generally create a prediction for another home that's not in the market that tells you more or less how much that home is going to cost. How do we do this? So we take information about the house, maybe its size, the year it was built, the size of the lot, its relation possibly to certain amenities, maybe how good the high schools are in the area, and they use all that information to predict a price. So this is a numerical output, which is why it's an example of a regression problem. It's a supervised learning problem because for each house that we use to train our model, we already have an observed value for how much the house costs. So we take all those historical observations and use them to train the model. Classification is another very common form of supervised learning. And basically what we do is predict an output label based on a set of inputs. So for example, you could feed a picture into a machine learning algorithm of an animal, and it might be able to tell you what species it is. How do we do this? Well, we feed the algorithm, in this case, generally a convolutional neural network. Don't worry, you don't need to know what that is yet, but we'll talk about that later. We feed these images into the neural network, and they learn, based on the labels that we've given them, certain features of these images that give it clues as to what species the animal might be. A completely different example, if we worked for a bank, we might use information about a client to determine whether or not they're likely to default on a loan, that is, not be able to pay a loan back. And that might influence our decision as to whether or not we should provide them a loan. So supervised learning has lots of applications, many of which you're probably familiar with in one way or another. Unsupervised learning, on the other hand, uses algorithms which take an unlabeled set of data points and asks you to find underlying structures or patterns in the data. So in the previous example with supervised learning, we knew prices of homes, or we had labels for what species of animal were described in the picture. Here we don't have those labels. Instead, we just take information about an object and try to find groups within the overall community of objects and try to find those that are more similar than others. So an example might be anomaly detection. So if you, for example, I'll use a case from the work that I do. If we were monitoring your energy usage over time, and all of a sudden we find a very abnormal spike, that would be considered an anomaly if we can't explain it by any other independent variable. So that would be an example of clustering points into groups that are normal or anomalous. A second example might be in online advertising, and that we could use historical buying patterns or internet navigation patterns of customers to find groups of people that have very similar interests. And that might help us down the road in our marketing campaigns. There's some other examples here that we won't talk about too much, and they're a little bit more difficult to describe with real world examples, such as component analysis or latent space analysis. But we might use these down the road in terms of learning about our data or pre-processing it before we go into other algorithms. Sorry, my slides skipped a little bit. Finally, we have reinforcement learning. This is a really cool application of machine learning that I've mentioned is growing in popularity every day. So in reinforcement learning, we have an agent. You can think of this as some kind of computer bot that interacts with an environment in which it seeks to achieve some goal. So a good example of this might be a bot that learns to play chess. It can learn by playing against itself many thousands or millions of times, and based on a system of rewards, maybe we reward it for winning a game and penalize it for losing a game, it will develop strategies that allow it to achieve superhuman performance. Right now, there's plenty of articles on the internet about using AI or ML to play chess or even the game of Go. And in fact, there's a very interesting Netflix documentary here that I've provided a link to, which shows the DeepMind team training a computer to beat world-class Go players. It's a fascinating movie, and if you think you'd be interested, I encourage you to check out the link on YouTube. One other example of this is self-driving vehicles. They generally learn in a simulated environment to safely navigate from a starting point to a destination. It can do this in a simulated environment by learning what actions it needs to take to avoid obstacles, get from point A to point B, and do so safely. So what do you need to do if you want to become a machine learning practitioner? So one of the first things we need to do is become familiar with at least one programming language. Most of the work in ML is done with Python, R, or MATLAB, but there are other languages out there that have machine learning libraries as well, including Java, C++, and Julia. In this class, as we mentioned, we'll focus on Python and a language called Octave, which is an open source version of MATLAB, basically meaning MATLAB is a very expensive software suite, but Octave is kind of a free version that's been created by the community and is open for anyone to use. Second, we have to learn the terminology and concepts. And we've actually gotten a great start on this already tonight. We've learned the three main classes of machine learning problems. Again, that's supervised learning, unsupervised learning, and reinforcement learning. And over the course of the remaining lectures, we're going to learn a lot more terms so that you can begin to associate different algorithms with different types of problems. To really excel in machine learning, there's a variety of academic fields that we also need to study. But our goal here is to get us started, get us excited, and prepare us so that we're ahead of our entire class when it comes time to jump into more complex machine learning classes. Within mathematics, you'll need to learn calculus and linear algebra, and it's good to have a background in a course called algorithms or numerical analysis, which basically tells you how to understand and manipulate algorithms and be sure that you're using them the right way. and understand how long it's going to take for those algorithms to run within the computer. And in computer science, it's important to, again, to be able to program effectively, be able to access databases, and down the road, when we start tackling really big problems, it'll be important to be able to parallelize our calculations, basically meaning run many of these calculations simultaneously via many computers or a graphical processing unit, or maybe even in the cloud. It's also great to read articles. So as I mentioned, this field is changing rapidly. Data science and machine learning have gained a lot of popularity in the last 5 to 10 years. And with that, people have gotten excited and have started making a lot of progress in the field. So books are great for the basic concepts, but a lot of the top-notch algorithms are changing from day to day. So almost as soon as you buy a book, it's out of date. So we can also recommend and maybe post in the Google Classroom some great resources for finding articles that should be accessible to a broad range of audiences. And lastly, you need to practice. There's a website called Kaggle, which hosts data science, machine learning competitions. It's something I still do today, even though I've kind of been an expert in this field for a while. But it's a good way to sharpen your skills and try new problems. Sorry, my daughter's going to bed, and it looks like we left her cat in the office. So we needed to grab that real quick. So yeah, once we get a little further down the road, joining a Kaggle competition is a great way to try out your skills. And it's actually a great way to learn from people who have been experts in this field for a long time. So Shreyas, at the beginning of the lecture, mentioned some common applications of ML, but we'll go through a few more here. So in energy, the field that I currently work in, AI and ML have been used by some really big names to manage the production of energy and manage how it's sold. So Google, for example, has looked at wind energy farms and have been able to do a better job of predicting the energy output of wind farms a day or 2 days in advance. And that's allowed them to create greater profits from selling that energy. In medicine, machine learning has been used in diagnostics, medical imaging. We'll talk about an example later on today, but like CT scans and x-rays have been read by computers now and have achieved accuracy even greater than doctors who have been doing this their entire lives. In finance, we talked about an example earlier, loan acceptance, trying to determine if a client is a good candidate for a loan. And at the high end, there are also folks who use machine learning for automated stock trading. Basically, designing algorithms which can trade stocks in microseconds and achieve great profit for their owners. In entertainment, these are examples you probably see every day. Tools like Netflix and Pandora have algorithms in the back end that help recommend maybe a new favorite show or a good song based on your interests. They are using tons of data from all of their clients and using those clustering principles to try to find people that are similar to you and find other songs that you might like or shows that you might like based on things that they liked. We've talked about a couple examples in gaming already, but also in government. Some of these uses of ML have come under scrutiny recently. For example, law enforcement using facial recognition software. Some of these things can be used for good, but they can also be used for bad. We at Community AI obviously are looking for ways to use these tools to help our community and help the environment. So while it's possible to use these for nefarious purposes, we're going to focus on the good applications. So let's dig in a little bit further on some of these examples. So this is an example of a Kaggle competition that was just released 1 week ago today. So this OSIC pulmonary fibrosis progression competition asks participants to predict lung function decline based on some basic patient information. So that might be patient's age, their gender, whether or not they smoke, and then some measurements of their lung function, and then a series of CT scans that are taken at a variety of times throughout the disease progression. So as they look at how the lungs are changing, along with some measurements, the goal is to be able to predict better than we can today, just using our traditional medical techniques on, what's going to happen in the near future for these patients in terms of lung function decline. So this is something that if you wanted, you could go create a Kaggle account and join today and use some of these regression tools that we're talking about to analyze these images. A second really good example is in fraud detection. So I'm sure almost everyone here is familiar with credit cards. And every time you swipe a credit card, whether it's at the grocery store or wherever, or on the internet, information is sent to your credit card company, and they have to determine whether or not they want to accept or decline that payment. Now, if your credit card has been stolen, obviously you can tell the credit card company that, and they'll decline the charges. But maybe if it's just recently been stolen, you don't even know it's missing yet. Well, the credit card companies often provide guarantees that their clients don't need to pay for charges that are made fraudulently. So they want to be able to determine a fraudulent purchase before you've even reported your card missing. Or somebody may have just stolen the digits off your card and are using it for online purchases. So we need to be able to determine in milliseconds, hundredths of a second, thousandths of a second, whether or not we want to approve a transaction. And this is a good example of classification. We've got millions and millions, probably billions of labeled transactions from credit card companies, where each transaction is labeled as fraud or non-fraud. So this includes a variety of types of data. There's numerical data. So how much was the purchase for? What time was the purchase made? How often does the client use their credit card to make purchases? When's the last time they made a purchase? There's also something what we call categorical data. So this is where data can fall into buckets or categories. So one category might be in-person transactions versus online transactions. Maybe a person never uses their credit card online, so it would be maybe odd if we experienced a new transaction that did take place online. And then also geographical data. Where was the location of the purchase? Is it where the customer lives? Have they made other purchases? Maybe they maybe they bought airline tickets on the card, and then there's new charges in the city that they were flying to. That would make sense. But if you found a charge halfway across the world, maybe it doesn't. And we can also track other things like the IP address of the purchaser and use all this information in a very, very short amount of time to determine whether or not we should accept or decline a charge. We also can look at an example of spam detection or spam filtering. So many of you already, even if you're in middle school or high school, probably get tons of emails a day. Some of these might be from companies you visited in the past or websites that have asked for your email address. And a lot of this information, or a lot of these emails are spam, things that you probably don't want to read. But there's also some nefarious spam where emailers might send computer viruses or try to gain your passwords so that they can use your account for other purposes. So it's really important for large corporate IT divisions to be able to determine what is spam and what isn't spam. If they can keep the bad stuff out of your inbox, it can save them millions or billions of dollars instead of getting, a computer virus which infects their network, or stealing passwords, which allows people to gather their data. This is an example of natural language processing, often referred to as NLP, which is a subfield of machine learning, which focuses on extracting information from text. So this is something that you probably don't think about as data on a daily basis, but can be treated as such. And there are a lot of algorithms which can take a paragraph of data or an email and learn information about it. So some aspects of spam filters might be very simple, like looking for a word or phrase that shouldn't be in there. But others are much more complicated, and those are essentially extracting meaning from text. This is a really cool example of reinforcement learning, and that's the example of traffic light control. So this is something that's probably frustrated some of you before. I'm sure not all of you are driving, but some of you probably are. You might be driving through a city and get a green light at one block just to find yourself at a red light 1 block away, and that process might repeat, and you might feel like traffic should just flow a lot better. It turns out that this is a very complicated optimization problem, especially in large cities, and traditional methods might not be adequate for solving this problem, especially as the traffic network grows larger and larger. So one alternative in a paper that was just written, I believe this year, uses reinforcement learning agents to control the lights on their own by trying a variety of strategies. In the reinforcement learning community, a strategy is generally known as policy, which provides rewards and penalties. So in this case, the traffic lights might be able to share information with each other, such as how many cars are waiting at a red light, or the rate at which cars are passing through the intersection. And all of the agents or traffic lights can work together by passing information back and forth to come up with an optimal strategy for when lights should be red and when should be green, and how they should work together to get as many cars through as possible. So a really cool application that probably impacts most of us on a near daily basis. And example 5, the final example tonight, is with recommender systems. So this is something, again, that you use probably almost every day. So the first example is Netflix. They've got a huge library of movies and television shows. And as a user, for example, myself, watches and rates shows, it learns the patterns of what I like and what I don't like. And it finds similar users. So, Shreyas might have liked the same show I did and disliked the same show that I did. And it might recommend to me another show that Shreyas has liked. So that's an example of a recommender system using some clustering type ideas to find similar users and provide recommendations. Another example that you probably use or have used in the past is Amazon. They've got millions of different products which they distribute across the globe. And each time you make a purchase or even look at an item, you don't even need to buy it necessarily. Amazon is learning what your preferences are, and it's learning from each experience. So it can provide recommendations for products which might go well with the products you just purchased, or it might suggest something entirely different than what you just purchased, but it might have learned a pattern that people like you have tended to buy object X after they purchased object Y. So these are very complex systems, but offer these companies a way to make lots and lots of money and increase their profits. So we've left some time here for questions, but we'll end with a few concluding remarks. Machine learning is a really exciting field, and as I mentioned, it's growing daily, both in terms of the number of practitioners of machine learning, the number of businesses that are employing machine learning, and in terms of the research which expands and improves upon the field of machine learning. You can use machine learning for really, you know, almost an infinite number of different applications. It's really up to the user's creativity and skill set to determine how to employ machine learning for the problem that they need to solve. So we at Community AI really want to help you build these ML projects that will benefit your local or global community. And over the next few weeks, we're going to discuss a few basic algorithms, which should hopefully increase your understanding of ML, but it hopefully should also get you excited about ML. And we'd love to partner with you on projects or learning, or if you found that maybe this lecture is too elementary for you, maybe you'd consider joining us as a mentor and help others work on their projects. So with that, let's take some questions. And I also encourage you after the lecture to visit our website at www.thecommunityai.org. All right. Does anyone have any questions? I'm trying to monitor the chat. I don't see anything there.
You may unmute and ask questions.
For example,
I have a question. So what's something that we cannot learn through machine learning?
It's an interesting question. So I'll tell you a challenge that I've faced regularly. We need generally data to solve machine learning problems. Now, sometimes we can simulate that data, but this has been an issue in jobs that I've worked before where there might be an interesting problem that we think we can solve with machine learning, but no one's collected the data. So generally machine learning problems need data, but beyond that, I'm struggling to think of anything off the top of my head. Obviously, you know, there's probably a variety of broad world problems like world peace and world hunger that can't be solved using machine learning directly, but we can probably use these algorithms to help aspects of this problem.
So would we be able to teach a computer how to do addition and subtraction? Because we have the data, but it's more of like a intrinsic concept.
Yeah, so that's something that the computer already has processes for knowing. It's already built into the logic. So I would say it wouldn't really be a worthwhile activity, but it's something that essentially could be learned. What might be more interesting would be to try to see if we could use AI or machine learning to do something more advanced like calculus.
So would we be able to teach a machine how to do calculus?
Theoretically, yes. It would need lots of examples of the rules and the logic. There's probably other ways to go about it, not using machine learning, but it's theoretically possible.
Okay, thank you.
Dr. Willard,
Yes.
so going off to the previous question, when you said like you could theoretically teach a computer calculus, like, so in calculus there's like different optimization problems, so is that what we could use AI to solve?
Maybe. I mean, it would be. Sorry, I'm struggling to answer this question. I'm trying to think through my head about how I would go about this. It would probably be a combination of using natural language processing to try to understand the syntax of an equation or a problem statement and try to convert that into a set of logical steps that the computer could then execute. So, I mean, that's kind of how I would approach the problem.
Okay, I see. Thank you.
I see the group chat is very busy. I've seen a few interesting questions regarding programming languages. Yes, the language R can be used for machine learning. I see Shreyas just answered that. In terms of what programming language you should use, that's really up to you. Python, R, and MATLAB are probably some of the most popular languages. I'd say that at least 80% of machine learning practitioners at least know Python. I would say that probably 60+% use it as their primary language. The only time you might want to use something like C++ or a lower level language is if you had an application that really required just crazy speed. But even Python has gotten very fast, especially with parallel computation and many of the libraries out there. So I would recommend focusing on Python, R, or MATLAB if you're going to learn a new language.
Okay, so I have a question.
Yep.
Okay, so how does a program determine the solution to a problem so fast, I guess? Because it's got to go through multiple iterations to figure out the answer, right? So how does it go through multiple records fast? Is it because of how far we've advanced in technology, or is it just a long process completed by multiple different devices?
Yep. So that's actually a really good question, and it's something we'll start talking about as soon as the next lecture. But machine learning is generally broken down into a few discrete steps. So first is kind of our data collection step. So we get all the data we need. Let's talk about the Amazon recommendation system, for example. They have all their data in databases, database tables that tell us, who made purchases, who visited what page. So we'd extract all that data from their databases. And step two is what we call training a machine learning algorithm. So we just decide on a model, and then we feed that model lots and lots of data, possibly over many hundreds or thousands of iterations. And during the training time is when it learns to establish those relationships. It might say person A is part of this group, or group X has these attributes. And so that's the time-consuming part, is the training of an algorithm. And then when we get to testing or production, usually executing a model is very fast. So these two discrete steps take place completely disjointly. Again, the training takes a while, but once the model has been learned, it can apply that model very, very quickly.
Dave, giving me the okay. Thank you for that.
Sure.
I have a question. Reinforced learning was the one with the reward system, right?
Correct.
for the. How does that reward system work? Because I understand how a human can be rewarded, because if you give them something that gives them the happy chemicals,
Yeah.
you want to do that more. But like, how does that work for computers?
Sure. So the computer itself isn't rewarded. You know, we're not giving the computer candy for doing a good job solving problems. Instead, what we do is we set up an optimization problem. So the computer is searching for an optimal solution. And the way it determines what an optimal solution is based on a series of numerical penalties and rewards. So in the game of chess, for example, we might give it you know, a reward of +1 every time it wins a game and a reward of -1 every time it loses. So basically, it will learn what strategies are associated with winning because it wants to increase its reward as much as possible. But that's only in terms of, when I say want, it's really the computer's programmed, or the program we write is designed to just solve an optimization problem, a very complicated optimization problem. Does that answer your question?
Yeah.
Dr. Willard,
Yes.
So are there gonna be any like, so because like there's some coding involved with making like programs, so is there gonna be a like a Jupyter notebook for that contains like code on how to do certain like programs?
Yep. So for Python coding, yes. I believe we already have one developed for Lecture 2, which Shreyas will be teaching on Thursday. He's got some Python code, which will do linear regression for a sample data set. We'll also be figuring out how to, you know, best share some Octave code as well, because as I mentioned, we don't really want to focus on any single programming language. So we'll be working to share examples of code in different formats and different languages, probably just limited to Python and Octave, on how to solve a variety of problems.
Okay, great.
Any more questions this evening? Okay. I don't know, Shreyas or Shaman, if you want to wrap up the evening. I guess we should encourage everyone to visit thecommunityai.org and also visit the Google Classroom, where there will be an assignment posted. Should be fairly easy to get through. It's only a handful of questions and a couple of open-ended short answer questions, so that we can learn about everyone's interests in machine learning and learn a little bit more about your backgrounds. Many of you have probably taken some classes before, or if you haven't, that's perfectly fine too. But thank you all for listening.
Yeah. Thank you, everyone.
Yeah.
Hope you had an enriching experience today.
Okay. And I believe if people have additional questions, we can post them in Google Classroom.
Yeah.
Is that correct, Trace?
Yes. Yeah, of course. We really encourage group discussions on Google Classroom.
All right. Well, thank you.